Let us see some of the common terms used in statistics. For example, box plots, outlier, percentile, odds, Pareto principle. Every day in day to day discussions, we might hear these common statistics terms. It is good that we develop some understanding of what these terms actually mean in statistics. First, let us look at box plot. This is how a box plot looks like. We have the first quartile, the second quartile, which we also call as the median value. We have the third quartile. This is the minimum value. This is the maximum value. And the minimum and maximum values are actually calculated based on the Q1, Q2, Q3. And then anything outside this minimum and maximum value, for example, these points would be termed as outliers. First, let us see what does Q1 mean, what does Q2 mean, what does Q3 mean. How the data is distributed, it is divided into quartiles. So this would be 25th, 50th, and the 75%. So when I say this is the Q2 or this is a median, this tells, or say suppose this value, the 50th percentile value is say 100K. Then a Q2 of 100K would mean that 50% of the people, say in this hypothetical example case where we are plotting salary in this box plot, it would mean that 50% of the people are earning less than 100K. And say suppose 75th percentile is 150K, then that would mean 75% of the people are earning less than 150K. This is how we read it. And this difference between Q3 and Q1, Q3 minus Q1 is nothing but range or the 50% of the data point in the middle. For calculating the minimum and maximum, there is a formula. We don't need to memorize that formula. It usually gets calculated via system. But if you want to know, minimum value is given by Q1 minus 1.5 times the interquartile range, which is nothing but Q3 minus Q1. Q3 minus Q1 is the interquartile range. And maximum value is given by Q3 plus 1.5 times interquartile range. So rather than having just an average value, if we have the box plots, we can quickly understand the distribution of data and we get so many more data points. Usually when we are analyzing salary data, it is good to look at data distributions because there can be some outliers such that the mean or the average value will not be a correct representation. The next is obviously outliers, and we've already touched upon the outliers, that anything outside this box plot will be outlier. In definition terms, any data point which is very far from the data points in this distribution, that is known as outlier. Now let us look at percentile. For example, in India, there is a competitive examination which is known as CATS, and the score in CATS is given in percentile. For example, if my score in mathematics is 80 percentile, what does this mean? It means that I am in the top 20%. It does not mean that I have solved 80% of the problems. No, or I have scored 80% in mathematics. It is a relative grading. It is when we are trying to compare things on a relative scale, how much I have got as compared to others, then we are using a relative scale and relative performance, then we use percentile. For example, if I have got 98 percentile in English, then what does this mean? This means that I am in the top 2%. Top 2% of the candidates who have all over the world written the examination, I'm in the top 2%. So this is how the relative scoring is understood by percentile. Now let us look at log scale and a linear scale. So linear scale is nothing but the normal scale. For example, if we have to plot the weight of students in the class, then I can plot the weights like this, right? Using a bar chart. Then I can plot, I can draw a density chart. I can use a normal scale and plot it. But what about if I have to plot the data based on, say, income in the US? Then it would be very difficult to plot the data on a linear scale because somebody would be earning, say, suppose $10 one day in a particular day, and somebody would be earning $1 million, $1 million in a day. That way, creating a chart and graph will not be possible. There will be so many data points in between. So that is where when we convert it into the log scale, we are taking a log transformation of the data. So rather than having data in absolute units, we are having in multiples of 10. And this is what it means when we say that we are doing a transformation of log. We are actually converting it into a log scale and then we are trying to plot. So every 1 unit increase in this log scale would be a multiple of 10. It will be 10, 100, 1000, and this scale we will use to plot, and that is why the graph would be actually available for us to view in in the dimension in which we want to see. Otherwise it would not be possible to view the chart. Now let us look at proportion and probability. So proportion is very simple. For example, what is the proportion of male employees in the company? So total employees are 100 and about 80 employees are males. So what is the percentage of males in the company? It is 80%. It is very simple. This is the proportion. But what is probability? Probability is different from proportion. We use the concept of probability when we are uncertain about the event. For example, whether it will rain or not. There is a probability that 60% there is a chance of rain. But it might also be possible that it might not rain. So probability is different from proportion, and probability is mostly used when things are uncertain. Now let us look at odd. You will mostly hear odds in games, gambling or betting. So what is odds basically? Odds is probability of winning by probability of not winning. So this is probability of winning and probability of not winning. If I say that the probability is 3:1, probability of winning is 3:1, which means that out of the 4 games I am playing, I have a good probability that I will win 3 games. This is very high. Then if I know this odds of me winning the game, then I'll definitely like to play the game. In day-to-day language, we usually hear in terms of what is the odds of winning or what is the odds of success. For example, you are doing this course and you are trying to learn statistics. So you are trying to maximize probability of you getting the job by learning and understanding statistical terms. So you are trying to stack your P to win. Now let us look at Pareto principle. Pareto principle is a very common statistical term that is thrown. What does it mean? It follows the 80-20 principle. This is the Pareto principle. It tells that 80% of the causes is caused by 20% of the factors. And this can be generalized to any business problem or anything. For example, 80% of revenue of the company comes from 20% of its products. Or you can say that 80% of the defects is caused by 20% of the product. This is how we generalize our interpretations when we say that it follows a Pareto principle. And it's a very common general rule that usually we see in business. So those were the common terms in statistics. I hope you learned something new, and I'll see you in my next video. Thank you.